With a meter changeout program in progress, the City of Galveston, Texas, prone to seasonal changes in water use and stress on their distribution system due to tourism cycles, deployed analytical sensors at key locations to optimize water quality and pressure monitoring throughout the network. Timely, low maintenance, and cloud-connected insights from online monitoring solutions allowed the City of Galveston to manage chlorine residual levels, address discoloration, and right-size its flushing program to limit water loss due to blind spots and dead ends. I'm Miles Skoda, and this is the WaterOnline Webinar series. Today, we're talking beyond the meter, level up your smart water system with distribution monitoring. So joining me for this presentation are two industry experts. First, Trino Pedraza, Executive Director of Public Works and Municipal Utilities with the City of Galveston, and Joe DeVito, Senior Manager of Utility Solutions with Badger Meter, who are going to help us understand operational insights that can be gained from distribution monitoring, discuss new technology that enables water quality monitoring without reagents and waste streams, and talk about how to build upon your meter program, incorporating quality and pressure monitoring tools for a smart water system that delivers greater insight. Now, we'll be holding a Q&A session following this presentation. Feel free to submit questions as we go along. We'll get to as many questions as possible during the Q&A, and any that we can't get to, we'll follow up on after the event. And then just a bit of housekeeping. If you run into any issues today, please try refreshing your browser first. If your problem persists, submit a question via the Q&A, and I'll help get you back on track. And then finally, this webinar is available on demand. Usually within a day or two, you'll get an email with a link to it, or you can just use the same link that you used today. So with all that said, I'm going to turn it over to Joe to get started. Joe?
Yeah, Miles, thank you very much. And you did a great job of kind of highlighting what it is that we're going to be talking about today. So first of all, who are we? I think it's important you understand who it is that's presenting here. Again, my name is Joe DeVito, Senior Manager of Utility Solutions with Badger Meter. I've been with Badger Meter just about 4.5, almost 5 years now. And before that, I do come out of the utility industry. I spent 30 years in the utility world, retired and decided to start a second career, and very privileged to work with utilities again and work in this smart water solution. I'm going to let Trino go ahead and talk a little bit and explain who he is, and he's going to take over from there.
All right, so I'm Trino Pedraza, Executive Director of Public Works and Utilities for the City of Galveston. I've been with Galveston for approximately 4 years, but I've been in the industry 15 to 16 years now. Today, we're going to be talking about Galveston, Texas. This is my home. This is a beautiful island. We're 50 miles southeast of Houston, Texas. If you look at the picture on the screen, you'll see that we're a very lengthy island. We're 32 miles long. This area is very beautiful. We have beautiful scenery. We're rich in history. It's the birthplace of Juneteenth. And one thing I want to focus you guys on is if you look at the screen, we're completely surrounded by water. We're off Texas, surrounded by water. And there's only a couple ways on this island. You can get here on a ferry at this location, or you could get here crossing the bridge at this location. So anytime anything goes wrong, it presents a challenge for us. So moving on, let's talk about our infrastructure. What you see on the screen are our stats of all of our infrastructure. And if I'd like to center you more towards our metered connections, if you look at our metered connections, it shows that we have 28,500 meters. That's not a very large system when you just look at that. However, if you glance over at our population, you'll see that we don't have just a population number, we have a range. And that's because this island is a major tourist attraction. We have beautiful beaches here. There's always a lot of people coming here. But we also have many events. We have Ironman competitions, a Lone Star Bike Rally, which is one of the biggest. We have Mardi Gras. And then on top of that, all the cruise liners come in and out of this area, which means anybody going on any type of cruise that are anywhere near Texas, this is where they're coming. So our population can swing from 53,000 to as much as 500,000. And that presents a lot of challenges operationally, which means we have to be sized to handle 500,000 at any time. Not to mention any of the other issues that come along with being on an island. So for example, what we have here is a list of issues that we deal with, or a list of challenges that we deal with living on this island. We talked about the population fluctuations already, from 53,000 to as much as 500,000. And then what that does is it causes swings on our peak demands. It causes swings on our pressure, which makes the pressure unstable at times. In addition to that, we're a very old island. We have a lot of old pipes still. And when you have old pipes, that leads to water quality complaints. And then just to make things a little bit worse, we're prone to weather events, extreme weather events. Any type of hurricane or storm surge is going to hurt us pretty bad. But on top of that, if you look at the picture, at the very bottom picture, you'll see that there's snow on the beach. We're built for the summer, and we handle the summer fine. We're built for hurricanes, and we can recover from hurricanes sort of fine. We're not built for winter, and all of a sudden we've been getting hit with hard freezes year after year. We're not built for snow on the beach, and so when that happens, it's pretty bad for us because most of our piping is exposed and shallow. And on that note, I'm going to hand it back over to Joe.
Thanks, Trino. Thanks for giving us an update of the island. And as he said, it is a beautiful island. I've had a number of times to be able to visit there and visit with him. So what we really started with Galveston is talking about an end-to-end smart water solution. He's going to talk a little bit how he decided to roll out an AMI program. And when he started rolling that out, conversations started happening about what we call a little bit of extensibility and being able to convert something into a smart water system. And we're real proud to say that that's really where the technology is going, and that's where we're heading. And as a former distribution operator, I think it's important to get beyond the meter and to understand what's happening in that distribution network. And this smart water solution allows you to do that. So for today, we're going to kind of be focusing on really these sensors. And we're going to be talking about water quality sensors, and we may touch a little bit also about distribution system monitoring for pressure in that aspect. And these sensors that we're utilizing and that we showed Trino and his staff are all cellular communication sensors. So it allows the information to get up into the cloud in an efficient manner, in an easy manner, without having to worry about a network and managing that network, and into a SaaS software system, and actually into the same software system that they're going to use to read their meters and see what's happening. So it's field deployable, it's easy for the guys to look at and figure out what's going on in their distribution network. So let's take a minute and take a look at a couple of these devices. And the first one we want to talk about is something we call the pipe scan. And this device is tapped directly onto the water main. It allows you to have no waste stream at all. It has a straw that brings the water up in there. It passes across the sensors, and it can monitor up to 10 parameters, including organics, which is important for some systems in that way. Without having any reagents in the system, with all being electrochemical, we don't have to worry about the waste stream at all, and it goes right back into the pipe. The other thing that's very impressive about this is the full event detection that's available with this. It'll send you real-time alarms. It'll let you know what's happening and when things are starting to change in your system in that way. It's mountable in multiple versions. The version I'm showing here is directly on the pipe, which works real well for in the network in locations like large meter vaults, vaults for hospitals, transfer sites when you're purchasing or buying water to other systems, booster stations, and where it comes out into that area. The maintenance schedule is spread out, about a 6-month maintenance schedule on this device. The second device we want to talk about is a battery-operated, a low-powered device. This device, as you can see here, is what we call the Metronet bollard. The bollard being it is self-contained in that one unit. It allows you to bring it out into your distribution network, get into possibly some residential streets or along some roads and mount this. It looks like a telephone pedestal in a lot of ways, and people really won't even understand what it is on the side of the road. But what it is something that's giving you insight into this distribution network and allowing you to see what's happening in that system in near real-time scenario. So whether you're monitoring chlorine, pH, whether you're monitoring turbidity in that aspect and you want to keep an eye on that, you'll be able to do that in the distribution network. Because it's battery operated, it's very simple to find a location that makes sense to you as a distribution operator where you want to put this. And again, no reagents involved with this, electrochemical sensors in that aspect, so you don't have to worry about the waste stream and where that waste stream might have to go. It allows you to have really proactive responses, and it allows you to gain insight. I know I've said that before, into what's happening. And I think Trino's going to help us understand what we mean by that when he talks a little bit about what he found out once these systems were installed in his network. So, I could stand here and talk all day about this. And the reason why I can do this is because it actually excites me. And the reason it excites me is because I operated a distribution network for 30 years. Retired after a 30-year career, wonderful career, enjoyed it and loved what happened in this. And when Badger Meter asked me to be involved in the water quality side of the house, because we were bringing that in after the purchase of some companies, ATI and SCAN, I looked over these products and I got excited. I was like, I can't wait to show these to utilities and to be able to work with utilities to show them how they can go well beyond the meter and get into the distribution network and understands what's happening. Because we want to reduce our labor, we want to react quicker, we want to be able to let our customers know what's happening, not them tell us what's happening and then us react to that. And this is giving us the ability to do that in that way. So with that kind of overall of what a smart water solution is, let's get into the nitty-gritty about what happens when you put one into the system and why you would do that. So I'm going to turn it back over to Trino to talk about what they did.
Wow, thank you, Joe. That's a tough act to follow. So one of the beauties about our industry is this. There are many forums out there that allow us to build our peer network, and there are many projects out there that allow us to expand our knowledge and our capabilities by connecting with other individuals who are passionate about their industry, just like Joe. And I'll tell you, the very first time that we met him was during our project kickoff, and he's sitting here. So sometimes you hear people talk, and when they talk, you really can tell who knows what they're talking about, who's lived it, and who's just following the script. And it was very obvious to tell that this guy had pure passion for the industry. And so at the time, my boss, who's the assistant city manager of Galveston, Brandon Cook, is sitting on the opposite side of the room, and we're texting each other, and we're saying, who's this guy? I would hire him right now on the spot, and so that was a conversation going back and forth. And I've never shared that with Joe, so this is the first time he's actually hearing it. But what our industry does is it allows vision to sharpen vision. And the reason we're coming back to one of these slides that Joe presented earlier is because a portion of this slide I had seen in the past. And as we described, we're getting ready to do a large system, which I'll talk about here. But as we were getting ready to look at how we wanted to roll our system out, what we wanted to do with our system, we were having a lot of water quality issues. And it was during this slide that I saw additional devices that I did not know existed. And at that point, we knew we needed to go a little deeper with our smart water solution. So earlier, I shared a screen that showed a lot of the challenges that we face here on the island. Our island had software and technology that was outdated, it was legacy, it was antiquated, it was failed in so many aspects. And we decided that it was time, enough was enough, and we needed to really move forward with advancing our system and preparing for the future. And so what that meant was multiple projects. We decided to overhaul our SCADA system and really get it going on the water side, and we're currently doing it on the sewer side now. We decided to begin upgrading our GIS software. We actually hired GIS technicians to work directly with Public Works and Utilities so they could go out there and do boots on the ground investigation, data collection, and asset and attribute data collection so that we could do our asset management program. We advanced our computerized maintenance management software. And then we decided to really go down the path of an advanced metering infrastructure, which is part of our smart water system. And with that, we went with a mobile endpoint. We went with all the bells and whistles, every piece of technology that Badger had available, we went with. We have the meters that have temperature, leaks, backflow, tamper, remote connect, disconnect on 100% of our residential meters. We have pressure monitoring with the distribution system monitoring system that they have, and we have water quality, which is what we're talking about today. Why did we go through that entire effort? Well, really, when you see the challenges that we face, it not only becomes important to modernize our system, but we really owe it to our customers, to our citizens, to provide them with quality service, a quality product that's resilient, that can withstand the challenges that we face and come back so that they can have their homes here and have a great livelihood. And in order to do that, we need to improve our system. We need the data so that we can make wiser decisions, make data-driven decisions. And so now let's talk about water quality. And as we move into water quality, I want to share a little story with you because you could say, well, why? What's so important about water quality? We have the typical things we always do in a distribution system, right? But as population grows, as the world changes, water is a precious commodity. And we got to be good stewards of that commodity. We got to take care of it. And I mentioned earlier that we have an old system and it was built in segments. So our system has quite a bit of dead ends. Not all of them have been found yet, but every dead end needs to be flushed, which is a waste of water for one. And then on top of that, it causes challenges with the quality of your water as the water ages at the dead end. So one day I am at the recreation center, the city-owned recreation center with my son. It's a beautiful day. We played some basketball. We go inside and we're just exercising and we're lifting some weights. And the picture that you see in front of you is actually from that recreation center. So while we're there and we're exercising, this group of young gentlemen come out of the basketball courts and they sit next to us and they start really hitting the weights. And one of the guys is extremely athletic and he's repping my max. And so we're kind of watching him in awe. And so as he's working out, he gets thirsty. He's out of water and he tells one of his guys, "Hey, can you go fill up my water bottle for me, please?" And the guy says, "What? You drink that stuff?" And at that point, my ears perk up and I start to listen to what they're talking about. And so the young man continues to say, "We don't drink that stuff here. That's sulfur water. You drink that sulfur water?" And he said the word sulfur water probably 8 to 10 times, at which point my son's looking at me because he's been around me the entire time I've been in the industry. He knows our business. And so he's looking at me with the eyes that say like, "Dad, what are you going to do or say?" And I'm looking back at him like, just shrug it off. But it's all in the eyes, right? And then so the guys, they end up finishing their workout. They get up and leave. We continue doing what we're doing. But my water bottle's empty now. So I'm going to go fill my water bottle up with my water. And I go to the water fountain and I fill my water bottle up and that thing is bright yellow. And I'm like, no. But the backdrop wall behind the water fountain is green. And I was like, it's got to be the wall. And so I pick up the bottle and I start just kind of angling it in different angles to see if it would change based on like a shadow or whatnot. And it doesn't. So then I pour it out and I fill it up a couple more times and I keep pouring it out. Then I take it and I said, no, it's the area. So I walk out to the sunlight and I see that it's yellow. And I'm like, no, this isn't right. So I take that back to where my son's at and he's looking at it and his whole face changes because now he sees sulfur water. And so we place that water bottle right next to his water bottle. And as you can see on the screen, that's the sulfur water. That's regular water from our fridge. Because a lot of times we fill up our water bottles and that was a filled up water bottle. So at that point, I call the guys up in our distribution staff, start getting them out there to flush the lines. And I start to speak to the recreation staff and they let me know that this is a common problem. Matter of fact, the director, Barbara Sanderson, says it would really be nice to go to a toilet that doesn't look like it's been peed in. because the water's yellow, and that's just embarrassing. So at that point, I brought everybody on board and I said, we're going to fix this. This is our product. We need to take ownership. And this is really embarrassing because this is our premier gym that has a lot of people that visit because it's right on the beach. Okay, so with that said, we developed an entire flushing program. We started trying to look at all of our lines, what needs to be pigged, what can we connect so that it's looped, what needs to be completely changed, how often should we be flushing certain areas, and it just evolved that way. And then as we were building that program out and we were starting to have successes, we needed to level up. And at this point, we're implementing our smart water system, and we know now it's time to install the water quality devices so that we could see what's actually happening in our system. So with that said, here's a picture of our system. Now at this point, we have 5 units. We have 4 Metronets and we have 1 Nano. This is where we're starting. This isn't where we're ending. This is the beginning of our water quality project when it comes to using these devices. So on the outskirts here, 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 and down here, these are our Metronets. These are connected directly to our distribution system in areas where we have a high level of complaints. In this area here are a lot of restaurants. In this area here is the University of Texas Medical Branch and all their students in a hospital. These are not good areas to get a bunch of calls. And then in this area here, we have our nano station, which was the location of the sulfur water. So now let's move on. All right, so here's the rec center. And you can see it's beautiful out here. Beautiful skies, it's clear. And the area where my arrow is right here, if I had a different picture, you could see the water's just on the other side of that. Right, so this is a big attraction to people, not to mention that the city gives grants to all children that live on the island so that they're able to work out for free without having to buy a membership. So that's important because then now we always have children in this place. I don't want to be giving children sulfur water. What you see over here on the left side of the screen is our nano station. So we use the wall mount station for this location. I will likely use some of the pipe installed ones in other locations, but here this just made sense for us. And so we use the wall mounted unit. This is inside the building because we wanted to capture the quality of the water inside the actual building. Okay, so now as we move forward, here are some of our installation sites on our distribution system. Now, if you look over here on the far left, here's a team of just talented individuals that work both in the distribution system and in our water supply division, right? So we have, going from left to right, we have Dennis Stark, who's the superintendent. We have Mark Glaser, who's a lead operator. We have Ava Caress, who's our proactive maintenance supervisor on the distribution side. And then we have Juan Bierman, who's the supervisor of the supply division. A great team, very technical, very enthusiastic about what they're doing. And then what you see in the next 2 pictures to the side of it are just a couple of our other installation points that we have that were shown on the previous map. As we continue, this picture here represents what it looks like, what the data looks like on our beacon system, right? So you can see you have a little map that shows its location, and this, we cut off a piece of the screen to make the picture fit, but here you can see temperature, you can see turbidity, and then you can see the total chlorine in our system. And then if you dive into the data and you go into the time series tab, you can really begin to see the granular trends of your data and see what's going on, see when it's happening, and then start to act from there, right? So right now, because the project's kicked off and we're just starting these up, we're going through some of the growing pains where we're calibrating the instrumentation that's part of the devices, where we're seeing how to use it. And we have meetings set up with a Badger team every 2 weeks so we could examine the data, examine the problems we're having, and start working through them to really fine tune our system before we begin to expand it out. And so the problem with having data is, well, one, you have to look at it, right, which is an effort. But two, you are no longer ignorant to what's happening in your system. And as part of this project, we saw something that happened pretty much right away that scared us. It was one of the initial issues that popped up, and it's a victory for the system. So shortly after installing the system and getting it calibrated, we have a residual that is well within our TCEQ limits, and TCEQ is the Texas Commission on Environmental Quality. And so it's well within our limits. And so we're all happy. Tomorrow we're having our meeting. We're going to sit down. We're going to talk about how the data is looking and what to do now. And what we see is this trend line just starting to go down and down and down and down and down, pretty near zero, just bordering the minimum limits that we're allowed to have. And so off the cuff, we're thinking it's instrumentation issues, it's data issues. And so we're having our meeting, and at the same time, the fire department's out there, and they're reaching out to Ava, who I mentioned on an earlier picture, complaining about the pressure at a fire hydrant. Meanwhile, the rest of us are looking at the data with Badger people, and we're seeing that it's really low. And so then we just ask the question, is it a problem with the Metronet, or is it actually reading properly? So we send our guys after the meeting, they get out there, and then I get that scary text that says, I've got bad news. Every director's nightmare, every manager's nightmare, every supervisor's nightmare. You never want to see, I've got bad news. And so what they share is that the system is actually reading correctly. And so then at that point, we get crews out and we start to examine what's happening. So let's dive into what was happening. All right, so here we go. Here's a picture of the area that was in question at that moment. The yellow dot that you see right here, that little water drop, that is the area of our Metronet, okay? And so what I wanted to do in this GIS picture was I took off all the layers minus the distribution system, and I wanted to highlight just some of the path of the water lines connected to the Metronet, because this is an area where we had problems. Our staff got out here and they began to investigate all the area. They started flushing fire hydrants and capturing residuals. And we were seeing residuals that were very low, and we just didn't know why. And so at that point, we start to question, well, are our pump stations producing the right dosing? And they go and they investigate, and it is. So the problem comes back to the distribution system. We get all the distribution guys out there, and we really start operating every single valve that's out there until we find the problem. So as we're doing that, we find a couple problems the first night, and we think we have a victory. So the first night that we're out there, which was the same night we had, or the same day we had that meeting, we find a closed valve here at this star, and we find a closed valve here at this star. Now, the fire hydrant that you see over to the right was directly connected to the valve that was located up here. It's actually this fire hydrant that I have the black arrow on right now. I actually put a couple out there so that I can focus your eyes there, right? So that fire hydrant in the picture is all the way open, but you can see the water is just barely coming out, and it is dirty as heck, right? So our staff finds that that valve is closed, and they open it up, and the residuals here, they pop right up to something more manageable or more acceptable. The water starts to clear up, but then they get back over here, and the area is still bad around the Metronet. And so they keep looking, and they find this other valve at this star closed, and then so they open it, at which point everything starts to clear up, and we think we're good. So we call it a night. So the next morning, I'm excited to get back into the Metronet, and I see the data, and for a moment there was a spike, but then it starts going right back down to the lower areas, and I'm like, what is going on now? And so the very next morning, that very morning, we send the guys back out there and they start looking at everything. And I get the text again, we got a problem. And so really what they're finding is that while we're still in compliance, the residuals are just at that borderline. And so the real question begins, what is going on with our system? We really start scratching our head. I start pointing fingers at every distribution person saying, see, I told you you need to be disinfecting the pipe when you put in a new piece of pipe and so on, right? And so we start going through all of that. Our staff's out there, they're operating everything, they're checking everything. And what we find are a couple things. We find some valves that were, well, not valves, but we find some dead ends that were not mapped. And so as we find those dead ends that are not mapped, obviously that gets taken care of. But we keep looking at the system, and I go back to the first picture that I showed you. And when we go back to that first picture that I showed you, if you really focus in over here at the total chlorine, what you'll see is that over this time period, every peak seems to be going down from the previous peak. Still in compliance, but it's going down. And then when you look over here, every dip is going down as well throughout the day. So there are little swings, and we're wondering, okay, what is going on here, right? Because we're tying it back to the issue that we're dealing with at the same time. So I sent our guys back, and I asked them, what is our dosing at the pump stations? And they come back. And so our staff is doing what they were supposed to do. They're really knowing their system. They're really getting involved with their system. And they were trying to make their dosing efficient for our system. So during the winter, they were maintaining like a 2 parts per million of total chlorine for our system, which is good, and it was holding. But I think as the weather started to change and we got into summer, the water is starting to get hot in our pipes because we're shallow and there's a lot exposed. And if you look over here, you can see that we have some decent temperatures. And every time they were flushing, they kept saying, well, the water was warm for a little bit, right? So what we end up doing is we increase our dosing by another part per million. So now we're dosing 3. At the same time, we're looking at the entire system, and everything seems to normalize after a day or two of all this work and flushing and whatnot. So that was a victory that came off of all of this data. Our final results is that we found 2 closed valves. We found 2 unmapped dead ends. And boy, I tell you what, when we found them and we opened it, that water was disgusting, right? So now they're on our flushing cycle. We adjusted our dosing. The total chlorine residuals normalized throughout our system. Wonderful thing. No more problem, right? And so ultimately, our project, we talked about enhancing SCADA and GIS and our work management system and our entire smart water solution. The whole goal is eventually to integrate multiple components from all of these different systems. While this is going on, we're also modeling our system. We've hired a consultant to model our system. We're purchasing modeling software. We're incorporating all of this data in, and we're going to use this to really calibrate our models. We're going to use that to help us really determine where we have capacity issues, where we need to change our storage practices, where we need to change pipe, period, right? Ultimately, as a city, what we want is our customers to prefer our water over bottled water. And then on the inside, we're hoping that with all this technology and the gradual and continued learning of how to use the technology and the data, that we will be able to bring some operational efficiencies when it comes to flushing, so that we're not just flushing and flushing and flushing. We're using the right dosing, and maybe even lowering some electrical costs. So on that note, we're going to move to our Q&A.
All right. And with that, Trino and Joe, this was a great presentation. Tons of great stuff. And we can certainly tell just from the excitement, how interested you guys are and how dedicated you are to this industry. So I have a good amount of questions from the audience coming in already. Audience members, I am highlighting the Ask a Question box right now on your screen. You should see that. I believe it's on the right side. And that will kind of show you where you can ask a question at. We have a few in right now, but we'll definitely be able to get to a few more. And if you did have any questions that we don't get to, I'm going to pass them along and they're going to follow up with them afterwards. So let's start right here at the top of our list. First question, are these water quality systems only for potable water?
Yeah, I'll go ahead and take that question, Miles. And the answer is what we've highlighted here today is obviously for potable water. But what we have is the ability to do both potable water, the wastewater stream, storm water. We can do pre-treatment, and we can do river and source water monitoring. It's just a conversation we need to have of what you're looking to monitor, and we have devices that can do all of that.
Good stuff. Thanks, Joe. All right, Trino, this is probably for you. What is Galveston's water supply?
Yes, our water supply is surface water. We get it from the Brazos River, and it is treated and sent to us from Gulf Coast Water Authority.
Good stuff. Joe, back to you. Someone asked a pretty general question here. They're asking what other smart water technologies are available?
Oh, there are a lot of smart water technologies available. What we're doing here at Badger is obviously it starts with the metering technology itself. What's available in there, if you move to the static meter, especially the ultrasonic meter, you can get temperature and pressure right at the meter level. We have the full line of water quality products that you've seen here now. We have remote isolation valves where you can restrict flow. That's a smart water device, possibly for somebody who doesn't pay their bill and you need to send them a warning. We have full distribution pressure monitoring, where we can monitor the distribution system for transient pressures, normal pressures, acoustic leak detection, and all of that can be brought back in as the smart water system that Badger's offering.
All right, great stuff. Thanks, Joe. Trino, I think back to you. Someone's asking who at Galveston is responsible for looking at the data that you collect?
Yeah, so that's a great question. And it's one of those things that we're still working through. So, our project is live right now. It's real time. We're going through the installation. Currently, there's a whole slew of us watching it. Our metering group is watching it. Some of our customer service reps are watching it. Many of the members of the Badger team, to include myself, will watch it off and on, and we're trying to figure out the best workflow. I think ultimately what's going to happen for us is that we are going to make the metering group responsible for looking at it. And here's the reason why. We have a pretty well-sized metering division. They're about 9 or 10 people. And it is not our intent to downsize them. What we realized with the system is that their role has just really transitioned, but the need for them didn't diminish, it just changed, right? So some other groups will start downsizing, thinking, oh, I'm automated metering and I don't need this group. We've seen others made that mistake. We learned from others. And so we kept them at that size so that they would have the staffing to transition into a technician for this type of system. So I think that's really for us where it's going to live.
That's awesome. Thanks, Trino. Let's see. So moving up the list here, we do have a good amount of questions coming in. So again, audience members, if you do have any more questions, definitely submit them now. If we don't get to them all, like I said, we'll pass them along. Or you can also reach out to our speakers. Their contact information should be on the left side of your screen in the speaker bio panel, along with mine as well. If you want to just reach out to me, I'll get you connected to the right person as well. So let's keep going. Someone asked, how does the system work when there is, a hurricane or something like that, and the cellular system is down?
Yeah, I'll take that question, Miles. So, that's part of the reason why Badger has moved to a cellular smart network, is because of the resiliency and what's available there. We're working with people. That's all they do is keep communication up and running. Everybody knows your cell phone's not going to be down a while, and they have multiple backups between battery power, generator power feeds to these They spend an awful lot of money on what they call cows, so cell on wheels. They've got drones that can put cell towers up. So that's part of the reason we've moved to this, to allow that network to come back up and running after these storms pass, so that we can get that information in that's important for cities and towns and municipalities to get back to the normal day of life.
Right. Good stuff, Joe. Yeah, that makes a lot of sense. Let's see. I've got a lot here, so let me get to this next one. Trino said that they monitor total chlorine. Do you also distinguish between free and combined? And how about free ammonia?
So we do. We have a water supply division that takes care of this portion of the system. They do not through the Metronet and the Nano, because of the way that we set it up. And then Joe, correct me if I'm wrong, but I believe these units do not do ammonia. So like we have the reads from these units, but our staff still maintains their current practices of capturing grab samples throughout the system and doing all the labs that they need to. And then what they do is they compare between the two.
Yeah, so Trino, you're right. You chose a setting in there, but the Metronet can do, which is the bollard unit that you've seen here, can do free, combined, or total chlorine. It's a choice that you make anywhere between 1 to 8 parameters. The system would decide what they want to put out there. As far as ammonia goes, ammonia cannot be done with a metroantic sensor like this, reagent free. That is wet chemistry. We do offer that device as well, and that can be communicated through the cellular system as well if ammonia is something somebody needs to add on to it.
Okay, good stuff. Thanks, guys. Next up, did you install automatic flushing devices on the dead ends that were found?
So on the dead ends that were found on this presentation, no, we did not. What we've done is we've just added it to our flushing list. In our system, we have identified approximately 350 dead ends, which is like a recent count that I just received from our supply group. We do have automatic flushers at a lot of the portions of the system. We're also trying to work with our distribution group so that they can connect a lot of these and just do some in-house construction. But when you consider the cost of the automatic flushers and the amount of dead ends that we have, that's a significant budget. So we're sort of picking and choosing, where it's easy for us just to have staff flush, where it's easy for us to have our distribution group connect the line so that it's looped, and then, where it's beneficial for us to put it out in the system so that we don't have to go up to that area.
All right, awesome stuff. Thanks, Trino. Let's see, up next, how many PipeScan and MetroNet are installed?
I assume that person, I'm not sure if they're talking about Galveston or talking about the system. Trino, why don't you say what you did in Galveston?
Yeah, that's a good point, Joe. So in Galveston, we have, as far as like the pipe scan, we don't have any pipe scans installed. We have the Nano, and which is basically the same thing, except ours is not connected directly to the pipe. It's a wall mount unit. And then we have currently 4 Metronets out in the system, and that was where we started. And then Joe, I'll let you tackle the other end of this.
Yeah, so as far as mounted and in use, these systems have been around for a number of years. They're used all over the world. The U.S. is just now really starting to adopt this technology and mount them in the U.S. We can reach out later. We can get you references if somebody's looking for somebody. Canada, the UK uses the Metronet a lot, and the pipe scan and the Nano station is used all over the world.
All right, thanks, guys. So I've got a kind of a generalized question here. They're asking, how do you identify leakages in the system?
Trino, I'll start with how technology can help, and then you can talk about what you do. Does that work?
Yeah, that works.
So to identify leaks in the system, there's a number of things which you start thinking about the smart water technology and smart water network. So like I talked about earlier, we have pressure monitors that have built-in acoustic leak detection right into them that they mount on the pipe, and they can monitor the system. They can be moved around onto hydrants. You can add multiple pressure monitors to monitor the system in that way. The software that we use, Beacon, with our metering, we can do DMA, so district metering. We can set up different zones. We can have a supply meter, demand meters, and we can tell you in real time or near real time what's going on in those zones so that you can look for leaks in that way. Trino, why don't you talk about what you're doing in Galveston?
So, I guess what we're doing here, we're just talking from the system perspective. We have, Joe mentioned the pressure monitoring component, and we have that installed and spread throughout our island. And so the pressure monitoring lets us know when we're having reduced pressure, and that's a big indicator of a potential leak, or someone else using significant amount of water. Sometimes it's us flushing. We get quite a bit of alerts from that, and when we do, we act on it pretty promptly. We also will compare that to what we see going on with our SCADA system to determine if it's a true issue. In addition to that, we use some of the typical, the typical leak detection methodologies with, listening devices and correlators and whatnot. We also will, beyond the pressure, we also will compare where we are having like a low amount of reads from our system versus what, let's say, the elevated storage tank in that zone is saying it's producing. And if there's a big enough delta, we'll start to focus a lot of crews in that area so that we can try to track down where that difference is, like where that non-revenue water loss is going.
Yeah, and Trino, you talked about having the pressure monitoring in your system, and you're deploying our Generation 2 E-Series meter in the 1N size on all your 1N services, which is going to give you pressure throughout your whole network, because our Gen 2 meters offer pressure standard in that offering.
Thanks, guys. Let's see. Next up, in our big list of questions, how are these devices connected to SCADA systems?
So I'll take that. That's a choice that the utility gets to make. We use standard out in the field, a cellular communication, but the devices that are out there can also be transmitted through Modbus and normal SCADA protocols. If you wanted that submitted into SCADA, then that's easy if you have that there. If you want it into a software that the guys can see it in the field like Beacon, then that's available as well. So that's a decision we make with the utilities when we start looking at the specific use case and where they're looking to install the units.
All right, awesome stuff. Next up, do you perform any additional treatment to the purchased water?
So what we do is many of our pump stations and elevated storage tanks have, have chlorine, and I guess it's LAS, and then we have corrosion control. So I believe that other chemical is zinc orthophosphate, I think, if I'm not butchering it. And so our staff monitors what our levels are at all of these stations. And then if they need to top it off in these areas, they will. Our hope too is by looking at these systems as we start to deploy them further out, is that it'll give us a good indicator if we're dosing properly or if we need to change what we're doing.
All right, good stuff. Thanks, Trino. Let's see. Can the consumer see any real-time information from their meters? And if yes, what is available for them to see?
I'll start with that, Trino, and then you can take what you've decided to do in Galveston. So yes, part of the Badger Meter Smart Water System is we include a civic engagement, so what we call ion water, with all of our deployments of the cellular system. And then the utility makes the decision when they want to roll that out or how they want to roll that out. It's not real time, what we call near real time in that way. So 4 times per day, the units are calling in. They're submitting that data on that app. They can set leak alerts. They can do a lot of different abilities to see what their consumption is and how their consumption, including embedding the ability to call their personal utility right from there or send them a message. Trino, why don't you talk about how you're deploying it?
Yeah, so originally when we went with this system, we actually chose a separate customer portal, thinking at the time that the ion water would not meet our standards. The ion water came with our system, and we ended up like activating it, looking at it, playing with it, and we realized it completely met what we needed. And so we ended up not using any other system. We stuck with the ion water. And so we've deployed it as of, I believe it was the middle of May. This past May, we finally began to deploy it. We're trying to get more customers engaged, but everything that Joe talked about, we have available for our customers. I guess that's it.
Yeah.
All right.
Yeah.
Awesome. Yeah. Thanks, guys. Let's see. Can the Badger water quality products be used by a system that does not have Badger meters or communication network?
Absolutely. So this product is not specific to utilizing the Badger Orion or the Badger Beacon system. It's a standalone product that can be installed. Like I said, multiple ways of doing communication protocols. If you wanted the information to go directly into SCADA, we can do that through a standard interface. So it's not specific that you have to have the Badger meters or the Badger Cellular Communication Network, Orion network. We can set this up to go into anybody's system.
Awesome. Thanks, Joe. A couple more here. We've got a few minutes left. I do see a note somebody asked, and a few other people did, will attendees be sent a participation or attendance certificate? If you do need an attendance certificate, just shoot me an email. My email is on the right side at the bottom in the audience preview, and I can send you back something saying that you did attend, so you do have a certificate of some type. Beyond that, let's see. Does the Badger distribution pressure monitoring sensor work with the Orion cell endpoints?
Sorry, say that again. I didn't hear the whole thing.
Yeah, no problem, Joe. Someone said, does the Badger distribution pressure monitoring sensor work with Badger's Orion cell endpoints?
It is not the same endpoint. If you're using an Orion cell endpoint for the meter, it's not the same. Obviously, this is a different amount of data and a different frequency. But it is a cellular communication that the same way as the Orion endpoint, Badger manages all of that for you and gets it connected.
Okay, good stuff. Thanks, Joe. Let's see. I think we can hop one more in here. Someone's asking, what factors were used to determine the location of the units?
So the current units, if we're talking about the water quality units, the factors were really, where are we having a significant amount of calls? And so we talked about the rec center in the presentation where we were physically seeing the discoloration and then hearing comments from people. And then one of the monitors that was focused on in the presentation, where we ended up getting the near zero read, there's a lot of restaurants on the main street there. And so a lot of them will start to call us when they see water quality issues because they can't run their soda machines and other things like that. And so we would get a significant amount of calls in that area, which didn't make sense to us. One of them was by the hospital, and over the course of the last 2 or 3 years, we've had just varying issues out there. We've had issues with pressure, and we've had issues with, chlorine residual and whatnot. And so when the hospital gets upset, it goes all the way to the top. And so trying to mitigate anything from happening in that area, was a factor. Ultimately, we plan to spread these out and have more in the system so that we can get a well-rounded view. But for an initial start, it was just where we have the most headaches. And then I'm sorry I cut you off, Joe. Go on ahead.
No. You were doing fine, Trino. I just want to say, That's exactly right. We sat down with Trino, we talk about it, we tried to figure out what makes sense for him. We look at the system together for the water quality, and we let them decide. I mean, a couple of use cases, I think on the pipe scan, a use case is definitely, an entry into your system where you're buying water from somebody else, an area where you might be selling water to somebody so that you can prove that you're selling exactly what it is that you say. On the pressure side of the house, we have a full network service engineers on staff that will look at the system with you for the transient pressure monitoring, and we'll decide together, and we'll give you a plan that says, here's the best solution that we think that would work for you once we understand your goals.
All right, guys. Thanks a lot. I think we're going to wrap up here. I do want to end with my same thoughts and the thoughts from an audience member who submitted a question that said, no question here, Trino and Joe, it was more engaging than a water system webinar has any right to be. Thank you. And so really, guys, this was a great presentation. I hope I know our audience had to have enjoyed it. There were a lot of great questions. If you guys had any more questions, reach out to Joe or Trino or myself. Our contact information is in the right side, or submit a question now and I'll get it along to them in the next minute or so while we're here. But with that, again, Joe, Trino, thanks so much, guys. This was a great presentation, really engaging, really good stuff, and definitely can show that you guys are super dedicated to this, and we appreciate that and appreciate you being here today. Audience members, again, thanks to you as well. We appreciate all your time and all your great questions. And with that, we hope you all have a great rest of your day, and we'll see you next time. Bye, everybody.